Okay, guys, today we are going to go over our first video together. All these files should be located under the current module on Canvas. As you can see, today we're going to be going over exponents. I'm going to upload the PDF for all the notes for this week under one big PDF. We'll work on it 3 different times this week. So today I'm going to go over the first 7 examples, which should be a review from Algebra 1. Remember that Algebra 1 is basically the foundations of your algebra classes, and then that just carries on into Algebra 2. So the things that you learned in Algebra 1 will show up quite a bit in this course, okay? So I'm gonna go ahead and hide my video right here, and then go ahead and start going over the notes for you. All right, so what we're gonna do today is called the product rule. All right, the product rule basically says that if your 2 bases, in this case the letter B here, but it could be any number or any letter for that matter, if your 2 bases are the same and you're multiplying them, then what you actually end up doing is you keep the base and you add the exponents together. So what that looks like is this one right here in example 1. All right, since they have the same base, which is going to be 3, all right, we keep the base and then we just add the exponent. And of course, you can do that in your head, and that's fine. Now, 3 to the 12th is a rather large number, so we would prefer just to leave it as 3 to the 12th. You could simplify that out on a calculator, but it's really not necessary. All right, so here's a nice thing about these notes is they're really detailed, and so if you miss something in the video and you just want to take a look at the PDF notes, they're also really well. All right, example 2. Now, on this one, we got 2 sets here. Now the parentheses are simply there just to separate the numbers. You really don't even need the parentheses because the parentheses here simply mean you're going to multiply. So if I scroll down here, you can see here that that's all that means is I'm multiplying. The other thing I added is this 1. If a base doesn't have an exponent, it's considered an exponent of 1. So just remember that as we get into some more problems. All right, so we're going to use the product rule to simplify. Again, all right, what we're going to do is try to put our numbers together. All right, so in this particular case, 6 times 3 is how we end up with the 18 number. X to the 4th is right here, x to the 1, so we're going to put those together. All right, and then we've got y values of y to the 3rd, y to the 7th, so we're going to put those together. And then our z value, we only got one of those, and that's going to go off here to the end. So the one that's definitely not going to change is the z because there's only one of them. But as we practiced in the previous one, all you have to do for your x and y values is just simply add the exponents. So 4 plus 1 is how we end up with 5, and 3 plus 7 is how we end up with 10. Again, the z value didn't change, and then we got 18 because it was 6 times 3. So that's just a pretty straightforward one. Again, there's going to be some practice problems like that that I will assign. Now, the other big one I'm going to go over today is called the quotient rule. All right, the quotient rule is basically a division rule. All right, so when you multiply or when you have a product, you add. When you have the quotient rule, when you divide, you subtract. Again, the bases have to be the same. If the bases are not the same, then you can't do this. So let's take a look at a problem with numbers in it. All right, as you can see here, they both have the same base of -3. So since they have the same base, then we can take care of their exponents by using the quotient rule. Again, the quotient rule states that we should subtract. So we keep the base the same, which is the -3, and then we take our exponents, 12 and 7, and we subtract. And so here, 12 minus 7 will give us 5. And that's going to be -3 raised to the 5th power. Now, on this one, it's a little bit smaller of a number. It's not 3 to the 12th like our previous one. So on this one, to get that -243, it's -3 times -3 times -3 times -3 times -3. There's 5 of them. And then anytime there is an odd number as your exponent with a negative base, such as a 3, you'll end up with a negative number. So that's why this is -243. All right. All right, example 4 is just a combination of the last two problems that we've done. All right, you just got to follow the rules. All right, this is division. So if you look at the 6 and the 30, you can't take 6 and divide it by 30. That's not 5. 30 divided by 6 is 5. So if they were switched around, it would be 5. But 6 divided by 30 is not 5. You can simplify it. You can divide them both by 6. So we can divide the top and the bottom by 6. All right, and then of course that would give me a 1 and a 5. And then of course I'm going to leave the other part the same. All right, now if we're following the quotient rule, after we've divided out our 6, then we can take care of our x's and our y's. And remember, when you divide, the rule is to subtract. So in this particular case, we're going to subtract. I'll go back up here so you can see again. All right, you're going to subtract your 12 minus 3, which will give us our 9, and our 8 minus 7, which will give us our 1. All right, and again, we've already taken care of the 6. We divided out the 6, but here it is in this step. Divide out the 6, and your answer is going to be 1 times x to the 9th y to the 1 over 5. The 1 is not necessary because it doesn't change anything, so you can omit that from the answer. You can also leave it in there. It wouldn't count against you. All right, the last one I want to go over today is what's called the power rule. All right, the power rule is basically what do you do when you have an exponent on the inside and an exponent on the outside. So let's take a look at a problem like that with some numbers. All right, so on this one, I know that 2 looks kind of big here, so I'll rewrite it. You have 4 squared, and then that's raised to the 3rd power. So on this particular one, we don't add the 2 and the 3. We don't subtract the 2 and the 3. We actually multiply the 2 and the 3. All right, so what that's going to look like is 4 with 2 to the 3, so that would be 2 times 3, which would be 6. The other way of thinking about that is this 3 means that there's 3 sets. So another way of thinking of that is 4 squared times 4 squared times 4 squared, because there's 3 sets. And then if you follow the product rule, then we can just add those 2's together. 2 plus 2 plus 2 will also give me the answer of 4 to the 6. So you got a couple different ways that you can do that on this problem. All right, and that's a decent sized number too, 4,096, if I were to simplify it. You don't need to have this memorized. You want to use your calculator to do this one. So you would type in 4, and you would find a key that looks like an upside down V. They call it the caret key in math. And then you do to the 6th power, and then that should give you your 4,096. So if you have any questions about how to use your calculator, then I can set up a Zoom meeting on that one, and we can go over that. But that's how you would do it. All right, let's take a look at this one. This is just going to kind of combine what we've been talking about here. Now, this isn't a quotient one. They're not dividing here, but we do have an exponent on the outside. All right, so the rule is that we have to multiply these exponents right here. Now, one of the ones that students typically forget is this guy right here. That 2, or negative 2, actually has an exponent, and his exponent is a 1. So he also is going to get multiplied by that 3. Again, that's a very common mistake, so be careful on that one. Let me show you the rest of the setup here. All right, so you can see here I've added my 1. Again, each one of these is going to get multiplied by that 3. So the negative 2, we basically cut it out. W to the 4, we cut it out. Y to the 5th, we cut it out. And then each one of those is going to get multiplied by 3. All right, this is again called the power rule. All right, so you can see here that 1 times 3 is going to be 3. All right, W to the 12th and Y to the 15th. All right, I can't do anything with the W. I can't do anything else with the Y, but I can simplify the negative 2. All right, so here's where we got. Now, the question is, how did they go from this answer of negative 2 to the 3rd to 8? Remember what this 3 stands for. That means there's 3 sets of them. So that literally means -2 times -2 times -2. Now you could do that on your calculator. Again, you could set it up as, on your calculator, you have to do parentheses -2 and the caret key 3, and that'll give you the -8 answer. Or you can just reason it out. -2 times -2 will give you a +4, and then +4 times a -2 will give you a -8. So that's how they got the answer of -8 as opposed to a +8. All right, last one. All right, this one kind of combines a little bit of everything that we've done so far. You can see here we have to deal with division. All right, and we also have an exponent on the outside, and we've got a negative in here as well. So we're gonna have to watch out for all of those. All right, first step, you notice that we added these guys. We added the ones. Again, if you don't see an exponent listed, that's an understood one. So it really is in your best interest to go ahead and write those down. All right, so each one of these, remember, has to be multiplied by that exponent on the outside. Everything on the inside is affected by that number on the outside. So in that case, it's a 4. So that means everything gets raised to the 4th power. All right, so we're going to have 2 times 4, we're going to have 1 times 4, and we're going to have 1 times 4. All right, so obviously 1 times 4 is 4, 2 times 4 is 8, and 1 times 4 is 4. So then we get this answer right here, which is not a bad answer, but it's not quite simplified. All right, the question is, how do you go from this to this? How do you go from -3 in parentheses 4th power to an 81? And again, remember what I said earlier, if you have this exponent, I mean, that's the number that we have. So it's -3 times -3 times -3 times -3. So that's a negative times a negative, which is a positive, and then a positive times a negative, which is a negative, and then a negative times a negative, which kicks it back to a positive. So, and then 81 comes from 3 times 3 is 9, 9 times 3 is 27, and 27 times 3 is 81. So again, we just simply multiply them out. That's going to give you the 9, that's going to give you the 27, and then the last one's going to give you the 81. So that's how they came up with that number of 81. Now, you don't move the X and the Z around. X was on top of that division bar, Z was on the bottom. X and Z are not the same base, so we cannot subtract them. So you can't do 8 minus 4. They have to match. Now, if they were both X's, then I could simplify them down, but they are not both X's. So on the first day, I want you to stop there, and then tomorrow I'll post a video as well for the 0 exponent rule. All right, it just adds a few extra steps from what we've just been practicing. So look out for that video. Again, you want to go sequential here. So do the first practice assignment, and then move on to the second practice assignment, and then the third one after you've watched the appropriate videos. If you guys have any questions, please reach out to me via email. And if we need to, we can set up a Zoom session. Check on Canvas. I'll post a weekly agenda. It'll be all your notes. It'll be all your videos. I'm going to try to post them at the beginning of the week for the whole week, but there will be some times where I will not post the video for, let's say, Wednesday or Thursday until it gets closer to Wednesday or Thursday. But the weekly agenda will be up on Monday, right, with at least the first day's worth of work, and then we'll progress from there. Okay. All right. So again, log in on Monday, see what's on Canvas, all right, and email me if you have any questions. Thank you, guys.